Hi everyone, this is Steve Christensen. Let's talk about storage facilities. What's the purpose of a water storage tank? Storage tanks store water when demands are low and distribute when demands are high. Distribution storage tanks drop during peak demands and rise during low demands. The main purpose is to provide sufficient amounts of water to average and equalize the daily demands. So, we certainly know that a lot of fire systems are tied in with potable systems. So fire protection, meeting the needs of reserve storage. We've been through this horrible drought, and most of the utility agencies, in my opinion, don't have enough storage. I personally think it should be mandated that there's 30 days worth of supply if everything was to really go down the tubes. But we certainly want to meet the needs for average and peak demands, and meeting industrial water needs. The other advantages of water storage tanks. Chlorinated water may be held for contact time. Power costs are reduced with off-peak pumping. It can serve as a sand trap to allow settling of sand and suspended solids. Inevitably with wells, there's a little bit of grit that comes up. Water can be blended to also meet acceptable quality when needed. Water blending is becoming more and more common, and what water blending is if one of your MCLs, your maximum contaminant limits, is over, you might want to actually mix with another water source that has a lower level, and it'll average out and get within compliance. So site selection, what are we looking for? Well, money is a driver on everything, but we certainly want to look at access to the sites, elevations available in or near around the area to be served, the relative cost of security, and the visual impact of a storage tank. We need to go ahead and have adequate covers to provide and protect against contamination. As of 2020, all reservoirs are supposed to be covered. That's a big hit for a lot of these small districts that have open reservoirs right now. It's very expensive to cover these. Drains and overflows shall be protected from cross connections to protect against contamination. The distribution reserve should be located as close to the center of the use as possible. And again, because of taste and odor and the quality of the water, we want to keep it fresh. We have several types of water storage tanks. We have ground level, which are standpipes and reservoirs, elevated ones, buried ones, hydropneumatic ones, and clear wells. What materials are used for storage tanks? Concrete, welded steel, bolted steel, and redwood. The upper picture is a bolted steel tank being put together. The lower left is a redwood, and the bottom right is a cast-in-place concrete. So here's a diagram of a water tank. What do we have? Let's start at the top. We've got a vent and a shoebox hatch. It always needs to be vented because otherwise as this water draws down, if it's not vented, it'll actually collapse because of the back siphonage and the pressure. And just like a tin can, it'll just fold right in. Your shoebox hatch always needs to remain locked. You have a locked ladder over on the side that's off the ground. It's always on a pad or foundation, depending on your soil conditions. I've seen them on both. If you have really good solid dirt, like a DG, you can actually go ahead and put on a gravel base and set it on that. But the majority of them are certainly reinforced concrete. We're talking about a lot of weight in these. This is a gauge over here. It's a float that goes up and down in the tank. So the lower the tank gets, the float goes up and reads on the outside of the tank. We have an overflow. The overflow is in case your pump sticks on, the water's got to be able to go somewhere. Where's it going to go? Down the pipe and out into some designed drainage. We have a drain that's flush with the floor. We have a gate valve that isolates that line. We have an inlet valve with another gate valve. And again, valves are our best friend. And we have an outlet valve. Now your outlet valve is basically, it's above the ground level because you're going to have sediment that builds up in here. You always want to have a screen or a flap gate on your discharge from your overflow. You need to make sure it's just really solid steel mesh, otherwise rodents can get up in there. So, this is a picture that, is about volume math. And I know we had a lesson on math, but again, this is pretty basic, and all of you should have a pretty good grip on this at this point. If not, I urge you to go ahead and get into one of the tutors. So partially buried storage tanks. What's the risk of those? Well, they can actually float right up out of the ground with upward force. Upward force is when you have a high water table and the tank empties, and it's like a beach ball. It wants to pop right up out of the air. You have all types of tanks, including some really huge submerged tanks. And again, these are very expensive. So again, we're talking about upward force. And again, that's a box 3 math pressure. Redwood storage tanks. There's a lot of them still out there. They were built out of the old growth redwood from way back at the turn of the century. And it's very valuable wood. If you're replacing that tank, you know what? You can sell that tank to a wood recycler. They remill it and they make it into flooring and all different kinds of things for decorative things. A lot of Starbucks has a lot of redwood storage tank pieces in them, actually. Clear wells. They're usually at the treatment plant. They're used for contact time in the chlorination process. What contact time is, it's slowing the water down because you want to make sure that your chlorine has an adequate chance to work and eat up those bad things in there before it goes out into the distribution system. Now, you certainly want to have some extra chlorine, which is your residual, so when it goes out into the system, it's still protecting from any contaminants that it could be picking up in the transportation through the system. You certainly need to make sure that you periodically inspect your tanks. It's just part of the gig. Bolted steel tanks are also called standpipes. And the definition of a standpipe is it's taller than it is wide. You have elevated steel storage tanks. You see a lot of these down in the flatlands. And the reason is you pump the water up and then you utilize gravity to distribute it through your system. Okay, so here's some examples of apparatenses, which are like gauges or anything additionally that goes on that system. It could be a pressure sensor, it could be an air relief valve, but it's not part of that core distribution system. It's an add-on. It's like an option to a car. And again, we talked about pressure. Head feet, 2.31 per foot per psi, and the head foot is 0.433 psi per foot. Standpipes are tanks that have a height greater than their diameter. Elevated tanks are used to maintain uniform pressure, but the pressure varies due to the tank level. Standpipes are preferred over elevated storage tanks when possible. They're safer to work around, more accessible for sampling and observation, easier to maintain. The standpipes made of concrete are easier to maintain than the ones made of steel, and standpipes can provide large volumes of water under low pressures. Hydropneumatic pressure tanks. You see these little blue ones all the time in residential systems, but they make them in all different sizes. This is one that looks like it's on just a small little well system. And again, what happens is the air is compressed up at the top, and it helps balance and push that water through and keep a nice solid balance. They're usually found in smaller water systems. They must contain the proper amount of air to be effective, and due to the high pressure in tanks, exercise extreme cautions. And the ones that are bigger in commercial systems, they actually have a big old compressor that's pumping that air up. So here's some big ones. You see a well house over here. And again, the air pressure in a compressed air tank automatically controls a water pump to start and stop. So again, it's all working off pressures. Lack of sufficient air can cause rapid start or stop and cycling in your pump, resulting in equipment damage. Cleaning a storage tank. It's the law now that these are supposed to be cleaned yearly. And this is one of those things that you see a diver going in on the bottom left. There's about 10 companies in California that do a huge business of divers going in with pool vacs, cleaning them out, inspecting them, making repairs. Now, the good old days, they used to drain these things. So you certainly understand the waste of water and all that kind of thing when we're talking about many tanks that are many millions of gallons. Troubleshooting. Using food-grade oil and pumps can serve as food for microorganisms or in storage tanks. And again, one of the things that we do is in this business is we either have water-lubricated pumps or sealed bearings. Because again, we don't want contamination near the water. Operators must be able to troubleshoot systems. And again, you're going to get things like color problems, positive coliform samples, taste and odors, turbidity. So some of the causes of water quality problems, it could be calcium carbonate, floc carryover, microscopic organisms, silt or clays. All reservoirs should be covered to reduce the possibility of contamination. You always want to be careful working around in safety hazards around water tanks. Again, you've got a confined space. So again, you need to use the proper protocol and follow policy. There's lots of OSHA regulations on this. And again, there's a lot of companies that specialize specifically in this. If you're working on a ladder, you want to go ahead and bolt in. You always want to use care when climbing ladders or stairs. On ladders on tanks, you know, metal corrodes, and a lot of these tanks are older tanks, so you always want to do inspection on your ladders also. Vents should never be blocked to prevent pressure and vacuum problems when filling. And again, safety procedures that should be followed: wear a safety harness, test the atmosphere for oxygen. The person trained in tank rescue is available at the tank entrance. Provide ventilation, especially when painting. Test atmosphere for combustible and toxic gases. And I would roughly say that the majority of operators are never going to be inside a tank because it is a confined space. Now, with that being said, the larger the organization you work for, the more specialized they get, the more equipment they have, the more things they'll do themselves. Security. Look at the top right picture. I've poisoned the water. What happens when you come to work and you see that? Well, you got to pay attention to it. Immediately, it's a 911 call. Get the word out to your customers. Do not drink any water. Start the testing process. You always want to make sure your gates are locked and keep out vandals, high school kids, and theoretically terrorists. This is something that since 9/11 has really ramped up through Homeland Security. And again, this is not what you want your lid to look like. So if you do get involved in painting, drying time is critical, as well as the temperatures that the painting is done in. You should not be doing it in the wintertime when it's cold. Oftentimes, these are very, very specialized materials. Cost hundreds of dollars per gallon. Best applied 60 to 80 degrees, that kind of thing. And obviously, they're all different with their spec sheets. Tank corrosion. Well, some of the highest paid people in some of the bigger utility organizations are the civil engineers who specialize in corrosion. That's because things cost so much in this for the infrastructure. And so they can afford to pay those design engineers and the corrosion engineers pretty much the same as what a general manager makes, which is a boatload of money. Starlight, Starbright. Well, hey, if you're in it and looking up through the lid and that's what you see, you've got some serious issues going. Disinfection. Disinfection is the inactivation or destruction of disease-producing organisms. Storage tanks should always be disinfected if it has had any opportunity for contamination. Once a tank has been disinfected, the water and disinfectant must be properly disposed of. Dechlorination. We're not supposed to be putting chlorinated water out into the atmosphere. But yet, on the other hand, anytime somebody's on a public water system and they hook up their hose, guess what? That's chlorinated water. Now, what you see on the bottom right-hand side is a dechlor machine that basically when you're flushing your hydrants, it does two things. It baffles and spreads out the spray, but it also goes ahead. Most common way to use it is with absorbic acid, which is actually vitamin C, and they put in a hockey puck sized piece of that, and it neutralizes the water, and that way it's healthier for the environment. But other things used for neutralizing are sodium bisulfite, sodium sulfite, sodium thiosulfite, and sodium thiosulfite is what you see in our little test jars that we use for our BACT tests, our coliform tests, and sulfur dioxide is another one. Vacuum in the system. Back siphonage may occur causing negative or below atmospheric pressure. Back siphonage from a cross connection in an unapproved water supply could cause contamination. Well, look at what we have going on here. We've got the kid in the pool. He's doing the kid thing. We've also have a garden hose coming in from the house filling the pool. Out in the system, you get a break. And what happens is the water reverses and sucks out, actually goes through the house, out into the system, contaminating the whole system. This is why cross connection and backflow and back siphonage are such an important factor. Vacuum in the system, what happens? Well, immediately you have to go ahead and do a boil water notice, and you start sampling. Flush the system to remove the contamination, and again, it's a boil water notice, which is pretty extreme. High pressure in the system. We use pressure regulating stations and pressure regulating valves that reduce high pressure to acceptable levels. Ideal at our households, we're going to want 40 to 60 pounds. Now, a lot of these systems work on gravity, and there's pressure zones if you think about it coming down the side of a mountain. Obviously, you're going to have more pressure down at the bottom than you would at the top just because of gravity and the way we know PSI works. Here's a little graphic of a pressure reducing stations, and again, you have your upper zone, you got a gravity flow system, and by the time you get to the middle zone, you're getting enough PSI coming down that you have to start putting pressure regulating valves in. Overflow vents on storage tanks should be screened, and again, otherwise you're going to get rodents, birds, snakes, all that kind of stuff going up those chutes and into the tank. I hate to say it, but it happens all the time. Abnormal operating conditions may occur when you have a broken or out of service pump, main, or tank, excessive water demands, stale water creating tastes and odors. Using electrodes to sense the water levels in tanks. Well, there's a lot of electronics that are going into this industry at this point. They may become corroded or become contaminated and thus requiring replacement. They hopefully are fairly easy to replace, although some of them can be real bugaboos. So again, when the electrodes need replacement or repair, they hopefully are not going to be difficult to reach. And again, just remember you're dealing with a confined space. What is the application of pumps? There's many application of pumps in water systems. Booster pumps. Well, booster pump does exactly what it says. It increases the pressure in the mains on the discharge side of the main pump. Centrifugal pumps cannot operate unless the impeller is submerged in the water. Pumps may trip out and produce serious problems due to electrical power outages when they are operating at full capacity, they're put online or taken offline. If if your source pumps are operating at full capacity, there's a danger of back siphonage conditions in your system. So this just shows a lot of the different types of pumps that we deal with. We have surface pumps, we have well pumps, we have low service pumps, chemical feed pumps. We have chemical feed pumps in our water treatment process with our flocculation, our sedimentation. We have backwash pumps to go ahead and backwash our filters. Sampling pumps to pull samples. Clear wells, okay, sometimes have pumps on them that, literally control the flows. High service pumps, and again, booster pumps. A pump may be primed so that the impeller is submerged in water with a priming water tank, air removal when using a vacuum pump, an auxiliary water supply, installing a foot valve in inlet or pump section of the pipe, and using a special primer pump to pump the water into the casing. Okay, well, this isn't coming to life, but anyway, what we've got is this is a little graphic that's supposed to be jumping around, and the squirrel keeps putting his finger in different holes as it's popping out, kind of like the little Dutch kid with the dam. Anyway, that's it for distribution in Chapter 2, and hope you're all having a great day. Bye-bye.